Hey everyone, welcome back to my YouTube channel. I'm myself Venkat. As you all know, I'm pursuing my engineering at Sri Venkateswara College of Engineering, Bangalore. I'm a third sem student of Chanakya class. Today, let's discuss the subject data structures and applications, and the topic is data structure and its limitations. The agenda of today's topic is let's know what are data structures, types of data structures, applications of data structures, and its advantages and drawbacks. First, let's know what are data structures. It is a specific way of organizing data in a specialized format on a computer so that the information can be organized, processed, stored, and retrieved quickly and effectively. Data structure it means it is a way of organizing the program in a specified format so that it is easy to understand the code. There are two types of data structures. They are linear data structure and non-linear data structure. Let's go one by one. First, let's know what are linear data structure. A linear data structure is a type of data structure in which the data elements are arranged sequentially, one after the other. Each element is connected to its previous and next element, maintaining a logical sequence. Non Now let's know what is non-linear data structure. Non-linear data structure is a type of data structure where the data elements are not arranged sequentially or in a linear order. In non-linear data structures, the elements are arranged randomly or in a hierarchical manner, with elements with each element potentially connected with multiple other elements forming a proper network or hierarchical system. Let's now the examples of linear data structure are first comes the array. Array. It is nothing but it is a collection of or a group of same elements. An array it is a basic linear data structure that stores a collection of elements in contiguous memory locations. Each element is in array is of same data types and the elements are indexed allowing quick accesses using the index number. The index starts from 0, meaning that the first element is stored at the index 0, the second is at index 1, and so on. As you can see in the figure, here u is stored in the index 0 and b is stored in the index 1. And if we come from last it shows -1, -2, and so on. Now let's know what is a stack. A stack it is a linear data structure that follows the last in first out LIFO principle. This means that the last element added to the stack is the first one to be removed. Stack allows the operation at one end called the top of the stack, and it has two primary operations. Push. Push it is used to add elements from the top of the stack, and pop removes the elements from the top of the stack. Here, the adding of elements takes place from the top of the stack, and here push condition satisfies. In the program, the push condition is executed when underflow condition occurs and pop for overflow conditions. Queue. A queue is a linear data structure that follows the first in first out FIFO principle. This means that the first element added to the queue is the first one to be removed. Queues follow insertion of elements at one end called the rear and removal of the elements from the another end called the front. A queue is nothing but a linear data structure where the insertion of elements takes place at the rear and the removal of elements takes place at the another end called as front. Here it is same as array where the indexing starts from 0, 1, 2 and 3 and so on. Now let's know what is linked list. A linked list is a linear data structure in which Elements are stored in nodes, are stored at the contiguous memory location. Each node contains two parts: data, the actual value or element, pointer, a reference to the next pointer in the sequence. Here, a linked list is nothing but it consists of a node. A node is nothing but it consists of two parts. One is data linked and linked list, where the data list contains of the data like the values 1, 2, 3 or ABC variables, whereas the linked list consists of the address of the another node. As you can see in the figure, here data is A and the next consists of the address of the value B. And for to identify the end of a linked list, like null character is used in the next section or in the linked list. Now let's go to non-linear data structures. A graph is a non-linear data structure consisting of a set of vertices, also called nodes, and a set of edges, also called arcs, that connect pairs of vertices. Graphs are used to represent networks and relationships between different elements. Here, a graph consists of nodes and edges, where it's nothing but it searches for the shortest addresses. Now let's know what are trees. A tree is a non-linear data structure that consists of nodes connected by edges, where one node is designed at the root of all the other nodes and organized in the parent-child relationship. For example, if you look at the figure here, 1 is connected to 2 and 3, and 2 is connected to 4 and 5, and 3 is connected to 6 and 7. Here, 1 acts as a parent node to the 2 and 3, and 2 act as a parent node for 4 and 5, and it goes on. Here, 2 and 3 acts as a children node for 1, and so on. Now let's know the advantages and drawbacks. Advantages. Data structure is a secure way of storing the data on a system. It helps us to process the data easily, and it helps in organizing the data in memory. Now the drawbacks. The algorithms are quite advanced. If there's any problem in data structure, it can be only solved by experts. And its applications: database management system, operating systems, networking, web development, artificial intelligence. Thank you for watching.